Okay, so you are very welcome once again into our tutorial series on how to build a low cost, portable, homemade power supply unit for prototyping circuits and systems on breadboard. So as you can see on your screen, we have this breadboard module, and on this beautiful breadboard there is this PCB module of a regulator is placed. How we placed it, we have explained that in our previous module. So if you are new right over here, coming and seeing this first time, you are encouraged to refer back to our previous modules. And we have explained that in few sentences how this module works, but now today is the time to actually test it. We now have a two supply voltages available out of this PCB, and what those supply voltages are. So let me use this guide as a lead. You see that there are 5 volts and 3.3 volts on this side available. On the right side, or simply say the other side, you also have 5 volt and 3.3 volt available. So with this module, when you will turn this on, you should be able to have 3.3 volt or 5 volt on either side of this module, which you can then use to power up your circuits that you will build in this area on the breadboard. You can see the placement of this PCB. This is module is fixed on the breadboard. Now to turn this module on, we need to provide an unregulated DC voltage of some value. Usually we have explained it in our previous module. The 9 volt is coming here, 9 volt DC unregulated, and the job of this PCB is to convert that unregulated 9 volt into either 5.5 volt or 5 volt or 3.3 volt. But the difference is these are regulated voltages. It means if there is a variations in the input DC voltages, some fluctuations, or there is a fluctuation or variation in the circuits, this voltage is 5 volt or 3.3 volt, whichever you use to power this, will remain constant. That's the definition of regulator. The regulator will maintain the constant output voltage which you are using here to power up your circuit, irrespective of the changes in the line or the load. Okay, there will be a percentage change in the load is your circuit right here, and percentage change in the line, it means whatever the input is coming here. Now 9 volt is coming here, and how this 9 volt you bring it, you see that basically this is a USB cable. So both ends are shown here. The first end I just told you, it is 9 volt coming here, and right here is the another end is going as an input to the laptop. So the laptop is providing input to this cable as a 5 volt, as you can see on the screen, and output this two-way cable is giving you is a 9 volt, which is coming right over here. So let us connect this end to the laptop so that 9 volt comes here, and turn this module on so that voltages which are regulated voltages are available here. We will turn this module PCB on. The LED will light up, and we'll then use a multimeter to just test whether we are getting those voltages or not. So it's a very interesting module. Let us proceed for the same. So as you can see now very clearly, this USB that is going inside your laptop, and this cable, let me bring you back to the breadboard. You can see now your breadboard is right over here, and this another end is coming right over here. So here it is. So our job here now is to turn this on, and you see the light is available. It means the module is powered on, and now you have the voltages available at both the ends. Now our job is to test those voltages, whether those voltages are available. So we will use a DMM, that is digital multimeter, and we'll see what voltages are available. So let us do that. So you can see now I have this digital multimeter right next to the breadboard. The PCB module of regulator on the breadboard is turned on, and we are all set to measure those voltages. So what the red lead goes to this side, that is voltage, ohm, current, etc., and there is this common pin where the black lead goes, and these are my two test leads that I am going to connect right over here. So let me take you to the pins right over. So instead of connecting these leads directly to those pins on the regulator PCB, I would take a chance to make a short circuit somewhere. So to avoid this, instead I will do one thing. I would use some wires to actually make the connections. For example, I use this wire and I want to test this side. So you see now, if you see closerly, there is this positive signs. Let me take you closer here, and if you can see that, if I can show you correctly, let me show you that if we can do that. Okay, so let me just take you closer here, and here you can see now there is this positive pin, there is this negative pin, there is this positive pin, and there is this negative pin. So what I shall do is to just make the connection. Let us have this positive lead here, and then somewhere here I place the another module. Let me do that for you. Somewhere here I put that lead over here. Next I shall do the negative one. Let me just connect the negative pin here, right over here, and another end I will take somewhere there, not in the same column but somewhere else, so that I can make effective measurement without short circuiting it. So these two leads or pins are available to me. Now my job is to just place the multimeter. For example, if you see now, if I place it right over here, I have to select the DC voltage. That's the voltage DC side. This is the AC voltage. I will put the knob and it is turned on. So I selected the 20 volt because the voltages I am going to measure is greater than 2 volt. If I choose it to be 2 volt, then there is a possibility that I will not be able to measure those 3.3 volt and 5 volt, and it is also not advisable to use the lower, always use higher. So 20 volt is okay. 200 would be much higher, no need. So 20 volt. And with that, let us now connect our leads. Black goes to black, red goes to red, and see what voltages we see. So let me make those connections, and I see now 4.96 or close to 5 volts. So it means you actually can, if you closely observe it, let me take you here, and I want to show you this cap. Let me switch it off first. This cap I have put in here. So this cap tells me I am selecting a 5 volt supply of it. If I take this cap and put it other side, then at the same pins, let me show you that. So what I want to say is, if I take this cap out and put it to the other side, then instead of at the same nodes, instead of measuring the 5 volt that we just measured, I will measure 3.3 volt, because I am selecting then here 3.3 volt. Let us try to do that. So what I shall do is, because I have to do so, I must switch off this PCB unit, otherwise I will make short circuit with my hands. So I will just take this cap, look at this cap is out, and now this cap I am placing right over here. And what I shall do, multimeter is already on, I will switch it, the module on, and I take my leads at the same nodes and see what voltage I see here. So let me just see 3.3 volt it should show me. Does it show me 3.3 volt or not? Let me just see what mistake I am doing. Maybe these wires are not connected enough. Let me connect them properly. And now let us put these leads and see what we measure. Okay, we are not able to measure anything, so there is some issue maybe. It's always not easy to measure that, right? Let me just so see, this is our chance to troubleshoot. So yeah, now you can see there is not a proper, now you can see I made this proper connection, proper contacts, and with that I can measure 3.3 volt, close to 3.3 volt. So successfully done, right? So yeah, once again, just make the proper contacts and you shall get the reading. I'm just wondering why I am not doing that. Let us do it very well. Okay, so let me just do it and see if we can do that. No. Okay, so now the proper contacts are established on 3.3 volt, close to. Okay, as you see, it's steady because I made a good contacts now. Otherwise it was just moving and was not able to do that. So always do that. Now next task is to measure this side. So what I'll do, I will switch it off. I will take these leads in this side, negative to the negative column, right over here. Okay, I have to make sure that okay, it goes now, and the positive goes to positive. You see that the close, very close. You don't have to mess up with the connections. You have to be accurate. Now I have selected 5 volt this side. This is 5 volt, this is 3.3 volt. Let me show you maybe closer. Let me show you the closer view. Let me show you the closer view here. Okay, you can see now the cap is on the 5 volt and the open things is 3.3 volt. So when we'll measure the voltage, it is going to show us the 5 volt. So let us do that. So again, I placed it, the voltage knob is set. Let us turn this on and we'll see 5 volt measured. So place these pins, multimeter leads, and what voltage we see, we'll see. Okay, there is something not effective, but you now see when you make a good contact with the multimeter leads, you have voltage 5 volt we successfully measured. Good. Next task, switch it off and now take the cap out, just, and then this cap goes to 3.3 volt, and now we should get the 3.3 volt here. Switch it on, come back with the leads and you just measure them, and you see now what voltage we are measuring. There is something we have to understand, that this is all about connections, making good contact. Oh, what's the problem? We are not, maybe here is the problem. There is this one. Yeah, now you can see, yeah, 3.3 volt. Okay, a good contact, and you got the reading. So that's it. So 3.3 volt came. So successfully we measured the voltages. So you see, if there is a circuit here, you can simply have these supply voltages through these red and black or whatever color wires, and get your supply to any node here. For example, just ground goes here, and then the positive, the 3.3 volt goes here. There is some transistor, there is a some IC whatever, and you need to put the voltages to the power input pins of that IC or a device. So hope you found this module useful. You understood how we actually can use the regulator module to provide a low cost power supply for breadboard prototyping. And with that, you also can see here there are some other pins available, like 5 volt, 3.3 volt, and there is a ground pin also. Closely, if you closely inspect that, and then you can just put some caps, select that particular stuff, and then from that you take those wires right over here. So that's a quite advanced topic. Well, I'll let it for the next when we'll actually build the circuits over here. So hope you found this module very useful. If you did so, share it with others, and for wider reach, stay tuned for more engaging concepts and tutorials and modules like this on electronics, circuit systems, designs, hardware, practical applications, etc. Till then, wish you a very happy learning.